Welcome back to another explainer. Today, we are decoding something incredibly cool: how artificial intelligence is evolving to process the world exactly like you and me. We're finally moving way beyond that era of text-only chatbots and stepping into a fascinating, multi-sensory new frontier.
So think about it for a second. Right now, you're listening to my voice, but you're also watching the visuals on your screen. Your brain is effortlessly stitching all that audio and visual data together so you understand what we're talking about, right? Well, until very recently, AI just couldn't synthesize data like that. It was literally locked inside a sensory silo.
Okay, let's look at how we got here. We started out with Multimodal AI. That's an AI that processes just one single data type, like a model that only reads text. From there, we evolved to Cross-Modal AI, which maps between different modalities. Think of generating a text caption for an image. But now we're arriving at true multimodal AI. These are systems with a joint, unified understanding across multiple data types at the exact same time. It is a huge leap.
Here is our agenda for today. First, the multimodal revolution. Second, inside the AI brain. Third, real-world applications. Fourth, overcoming system challenges. And finally, the future of AI.
Let's kick things off with Section 1, the multimodal revolution, shifting from single input to multisensory.
The absolutely crucial takeaway here is that this new paradigm allows machines to process heterogeneous or fundamentally different information simultaneously. Imagine an AI that can ingest a sequential text document, a spatial high-dimensional image, and a temporal audio file, all at the exact same time. It's a massive leap forward designed to closely mimic human cognition. Because, our brains constantly derive context from all our senses working in tandem.
All right, moving to Section 2, inside the AI brain, where we look at architecture and fusion layers.
Everything basically starts at the input processing layer. You can think of encoders as the digital eyes and ears of the whole system. You've got language models for text, vision transformers for images, and spectrogram-based models for audio. Their main job is taking that raw data and converting it into what we call embeddings. And embeddings are essentially mathematical vector representations. They turn a spoken word or a picture into a universal digital language that the AI can actually compute.
And that brings us to what is essentially the AI's brainstem, the fusion layer. This is the core integration mechanism. The really big challenge here is figuring out how to align all those different digital signals, the text, the images, the audio embeddings, into one single unified thought. Developers usually refer to this as a shared semantic space.
Now, developers actually choose how to fuse all this data depending on how complex the reasoning needs to be. So if it's a pretty simple task, they might use early fusion to just combine the raw inputs right at the start. For highly modular systems, they might lean toward late fusion, where everything is processed separately and the outputs are combined at the very end. But for true highly complex reasoning, systems rely on hybrid fusion, which integrates the data at multiple different stages along the way.
To genuinely understand context, the AI relies heavily on two major concepts. First, we have cross-modal representation. This basically means the AI learns that a picture of a car and the text spelling CAR point to the exact same real-world concept. Second, we have attention mechanisms. This is what allows the model to dynamically focus on what's most important at any given moment, like perfectly synchronizing a really fast-moving video feed with its corresponding audio track. Finally, we reach the reasoning and output layer. If encoders are the eyes and ears, this layer is the AI's mouth and hands. It takes all that beautifully fused sensory data, performs contextual understanding, and actually executes a decision. That output could literally be anything: generating a quick text summary, drawing visual annotations on your screen, triggering an alert, or even executing physical actions in robotics. Real quick, just like this AI needs multiple continuous data streams to thrive and grow smarter, this channel needs you. We are on a mission right now, and we would be absolutely thrilled if you could hit that subscribe button to help us hit our 1,000 subscriber milestone. Seriously, your support is what fuels our continuous stream of deep dive explainers, so thank you.
Okay, jumping back in. Section 3, real-world applications. Let's see how this tech is sensing the world.
The flexibility of multimodal AI out in the wild is just incredible. Take healthcare, for example. It drastically reduces ambiguity. By ingesting both a complex medical image and a doctor's text-based clinical report at the exact same time, the AI significantly improves diagnostic accuracy. Or look at automotive systems. Self-driving cars are using sensor fusion, combining spatial cameras, radar, and LiDAR to monitor the driver inside the car while simultaneously tracking the highly dynamic environment outside.
And this scales up seamlessly into corporate environments too. By pulling together structured data logs, text documents, and real-time dashboards, multimodal AI creates deeply context-aware insights for enterprise analytics. In the security space, merging live video, audio alerts, and anomaly detection creates a super robust threat identification system. We're even seeing it in everyday human-computer interaction now. I mean, your smart voice assistant can literally look through a camera to visually understand exactly what you're asking it about. How wild is that?
Section 4. Overcoming system challenges. Let's talk about the roadblocks to true cognition.
As incredible as all this sounds, building a digital brain is incredibly taxing, and honestly, we aren't quite at perfection yet. Aligning heterogeneous data is highly expensive and super complex. Just collecting and properly labeling massive multimodal datasets takes immense human effort. Then, of course, you have scalability. These larger models require heavy, power-hungry GPU acceleration. Plus, we constantly face alignment issues, where even a tiny misalignment between an audio and video feed can seriously degrade the system's overall performance.
Bringing us to Section 5, the future of AI and unified foundation models.
The future points directly toward unified foundation models. We're talking about a single, massive architecture built from the ground up to handle all modalities seamlessly at the exact same time. We're going to see vastly improved real-time reasoning and, crucially, a huge push toward edge deployment. This means running these complex models directly on local devices for super low latency applications, making these systems infinitely more adaptive and integrated into very specific domains.
As industries increasingly rely on these complex data ecosystems, multimodal AI is going to be the central pillar of intelligent design. It's a fascinating leap forward, but it really leaves us to wonder, when a machine can simultaneously see, hear, read, and reason with perfect synchronization, just how blurry will the line between artificial calculation and human-like perception ultimately become? That is something we are all going to get to witness unfold.